So, Professor Medzhitov, the common cold is one of the most frequent diseases. We all suffer from it several times a year, and still we have neither vaccine nor therapy for it. So what is it that makes us feel miserable and ill?
So, like with any infectious diseases, when we have common cold, most of the symptoms that we know of, symptoms that actually make us feel sick, come from the defenses, the immune defenses that aim to protect us from the rhinovirus in this case. And these defenses, because they have such an important job of protecting us, they come with a cost. Just like military defense can come with a great cost. And sometimes we can feel the cost more than the actual threat. So in the case of infectious diseases, these costs are called immunopathology. And so the running nose, fevers, headaches, and so on during the common cold, these are all the costs of the immunity. And this is one fundamental aspect of infectious diseases. So symptoms, most symptoms of infectious disease are caused by actually immunopathology. But if we don't pay those costs in the case of infectious diseases, then the problem will become the pathogen, and then we will pay the bigger cost. And that's why evolution created this type of a costly defense that we pay for.
Thank you. Professor Kaufmann, may I ask you, the best treatment for infectious diseases, of course, is prevention by vaccination. There has been great progress in that field in the past centuries, the past decades. Yet there are still open problems. What do you think are the future challenges and chances of vaccination?
Well, I think vaccinology has done what could be done by trial and error, and it's now a new area of vaccine development, and that needs immunology. This is not looking down to what we have established. Current vaccines save 5 million lives a year. And for every dollar or euro we spend for the development of a new vaccine, of those we now have available, $20 or so are a return of investment by preventing disease and death. But yet, the vaccines we now have to develop, vaccines against the moving targets like HIV, TB, malaria in the infections, the vaccines that could prevent some cancers, vaccines against autoimmune disease, allergy, these really now need science, and the science is immunology. And I would like to cite Bill Gates, who supports a lot of vaccine development, mostly for poverty-related diseases. Immunology is very important because it's the science that teaches us how to make vaccines. And vaccines teach our immune system how to block the disease. I agree with Ruslan that a lot of damage is done by the pathogen, by the immune system, but ultimately, if you can prevent the pathogen from establishing itself, you will also prevent the downstream events of immunology. So I think the big questions now are, can we develop vaccines against the moving targets, the hard ones? I think it takes time. It will take another 10 years or so for a first breakthrough. But I think we are on the time to witness enormous success of vaccine development in the future, a long way even further and beyond infectious diseases in principle, but also to the so-called non-communicable diseases. And I always like to remind you that we already have 2 vaccines against cancer, hepatitis and HPV, human papilloma viruses, because those are caused by pathogens. And by showing that we can prevent these cancers, we also show that there is not a real distinction between communicable and non-communicable diseases, and the principles of immunology hold true for both aspects of health and disease.
Thank you very much. Professor Endres, your own work is focused on immunotherapy of cancer. This has periodically been subject of very excited and largely misleading tabloid reports. What would you describe as a realistic expectation?
Vaccination against infectious disease is a triumph of medicine, a triumph we have had for 200 years. But what is the vaccination against cancer? There are 2 kinds. One is to prevent cancer, and one is to treat patients who already have the disease. The last century we have made a huge discovery, and that is that infections can cause cancer. And this has led to the fact that we can vaccinate patients against papillomavirus to prevent cancer of the uterus in women. And it has led to the fact that we can immunize against hepatitis. And this allows us to prevent cancer of the liver in hundreds of millions of people. So there's one way to prevent cancer by vaccination. It is via infectious disease. But there's also a second way, that is to vaccinate directly against cancer cells. And commonly we think of vaccination as two things. First, it's before the disease, and second, it's against infectious. Both is not true. We now know that we can induce an immune response even in the patient who already has cancer. And the most exciting strategies for this is that we can identify small molecules, so-called peptides, from the cancer patient and vaccinate the patient against these peptides, and this allows a cell response that will kill the tumor cells. So this is a wonderful bridge that immunology bridges to immunology. And if Ruslan will find new discoveries about how the innate immune system works against viruses and bacteria, we are eager to use your discoveries to turn them against cancer cells. So in summary, these 2 decades of this century are a wonderful time to work, to do research in immunotherapy of cancers. Yes?
Thank you very much. Research is done by people. Therefore, the future of science lies in the education and training of young scientists and of future award winners. So, Professor Medzhitov, you get many applications for Ph.D. or postdoc positions. When you are selecting team members, what are you looking for? What qualities does it take to make a successful scientist?
Well, for me, I think the most important quality is the love of science and the passion for science. Because being a scientist is probably the best job in the world if you really love it. It can be also a very frustrating job if you don't love science. So it's also, you can't be really good at anything unless you really love it. So my first criterion is that I select people who really love science. And any deficiencies in skills and techniques or even education they may have, that can be compensated. But if you don't love something, that can be compensated. So that's my main criterion. And I also, of course, like anybody else, look for people who can be creative and who are very dedicated to science and to enjoying doing research. But my main criterion is the love for science.
Thank you. Professor Kaufmann, what kind of training and setting is needed to let young talents unfold?
Well, first I would agree with Ruslan that empathy or passion, that's a very important factor. I'm somehow getting older and I see that as well is always better than either or. I would also add that you need a good infrastructure for sure. You nowadays need and depend on high infrastructure quality equipment. And I think also that you want to give a certain degree of guidance. You want to leave the young scientists a lot of freedom, but at the same time they also need some mentorship. And I would also add that I consider it, which was mentioned before already by our minister today, multidisciplinary is a word that's been used perhaps too often, but it's also very important to see that you, as an immunologist nowadays, are insufficiently equipped if you just do classical canonical immunology. You need protein chemistry, you need modern technologies outside of our field. So if I may say, I think summarize, yes, motivation, empathy, passion is important. Good infrastructures are important. That's why we need the money and hopefully spend it wisely. And perhaps one more point is that I think coming newly into a lab, I think follow first to the hypothesis given perhaps by the mentor or your own, but be always open to changes. And if there is experimental reason to change, then I think you should follow that new pathway. And I may cite Louis Pasteur once more. Chance favors the prepared mind in the field of scientific observation, and I think that is clearly important. Suddenly, somehow, in your experiments, you find something unexpected, and don't throw it away. That might be the kind of the new thing that comes up. And perhaps also another phrase, I'm good in phrases today, using a lot of them. Don Rumsfeld, you may look at him in different ways, but I think he's right in immunology and science if he says we don't know what we don't know. These are the things that get you excited. These are the things you want to find that you didn't, nobody else before did know actually.
Thank you. Professor Kaufmann, medical research, Endres, sorry. Medical research needs the clinician scientist, bridging clinic and research, and being equally competent in both worlds. How can we convince bright young people to take on this double challenge?
So I'm rather familiar with this dilemma because I lead a research department, immunopharmacology, within an internal medicine department at the University Hospital in Munich. I once talked to a very distinguished Professor Emeritus in Boston about this, Professor Paul Russell, former chief of surgery at the Massachusetts General Hospital, about this dilemma. And he said, combining patient care and research is impossible, but necessary. I found this very wise. It brings to the point that with patient care becoming more and more sophisticated and specialized, it is increasingly difficult for one man or one woman to combine competence in both. And the only way we can foster this is twofold. I see several deans of medical faculties here in the audience. We have 33 medical faculties in Germany. It's an honor that several faculties are represented here, in addition to Yale. And I think it's you, the deans of the medical faculties, and you, the CEOs of the university hospitals, whose responsibility is to provide protected time for young physicians for 1 year, for 2 years, for 2.5 years, that they stay within the hospitals, but that they get an excellent basic science education. And only if we do this, we will avoid that biomedical research will fall into two parts. One will be the specialized physicians, and one will be the biologists, and they may not be even talking the same language. So I think it's a great responsibility, but also to the funding organizations, like the Kröner-Fresenius-Stiftung, who has put up excellent programs to address exactly this Berufsbild, this professional aim as a physician scientist, either by individual stipends for 2 years or by establishing so-called Forscherkollegs, where 10 physicians are bundled together to do basic research for 2 years. So those I see as the two main tasks to reach.
Thank you very much. Let me close this round of questions by a last question to the award winner. What is the most important difference the award will make to your laboratory?
Well, so modern science, including immunology, is becoming increasingly more and more fragmented. We have, first we had several specialties within immunology, now we have subspecialties of subspecialties and so on, and it's become increasingly fragmented, and it's a necessary phase in development of any science. It allows us to get into much more details that we otherwise could. But the negative consequence of it is that we start sometimes maybe losing the big picture and losing the connections between different branches of science. And the traditional funding mechanisms, they actually promote that even further because they generally tend to be conservative and prevent going into unknown. So this type of an award would enable to do the opposite, to try to do what I always wanted to do, is to, instead of specializing further and further in specific areas of interest, is to try to integrate them with areas that were not even traditionally have been studied in immunology, including the ones that I mentioned, like links with endocrine system, with homeostasis, various aspects of physiology. This is the type of research that can be only enabled by these types of awards, and that's what I'm hoping to do with it.
Thank you very much.
Thank you.
Meine Damen und Herren,